Exercise 2.2, question 2. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. Well, there are many parts to this question and we will spend maximum time on understanding the first part because all of the others are really just the same. So what is happening here is that we are given the sum as 1 by 4 and we are given the product as minus 1 of what? Of the zeros of a quadratic polynomial. So zeros of a quadratic polynomial, these correspond to the points where the graph of the quadratic polynomial cuts the x-axis or where the value of the polynomial is 0. For example, if this is the xy plane and this is the graph of a parabola, which will be the graph of a quadratic equation or a polynomial, you can see that these are 2 points where the graph is cutting the x-axis. So these two correspond to the zeros of this quadratic polynomial. Well, now what we have to do is we have to go in the reverse direction and find the quadratic polynomial whose zeros will have this sum and this product. If you go back and look at question number 1, you will see that there we were given a polynomial. We had to find the zeros and then we had to see what about the sum and the product. Well, this time, let's use this page from the book and see what to do. Well, we know that if we have a polynomial p of x, ax squared plus bx plus c, a quadratic polynomial, with x minus alpha and x minus beta as factors, then its zeros are alpha and beta. And then we know that the sum of these zeros, alpha plus beta, is minus b by a, and the product of these zeros, alpha multiplied by beta, is c by a. Now, what are you given in this question? You are given these two things, the sum and the product. So they're telling you alpha plus beta is equal to 1 by 4. Let me write that down. So alpha plus beta is equal to 1 by 4. And that alpha beta, which is the product, is equal to minus 1. So these are the two things you're given. Now think about it. You don't have the quadratic equation, so you cannot find its factors. So you cannot find the zeros and you cannot find the sum and the product. This time you have been given steps 4 and 5, the sum and the product, and you have to go back all the way till step 1. Now think about it. Just use this relationship number 4 here. So sum is equal to minus b by a, which means this 1 by 4 is equal to minus b by a. Similarly, product is equal to c by a. Now these are two relationships that we will use to find out a, b and c. And the moment you get a, b and c, you will have the quadratic polynomial that you were looking for. Now here, just be very careful. Everything really depends on a. Think about it. If a is equal to 1, I'm just randomly taking a value. If a is equal to 1, then minus b by 1 will be equal to 1 by 4. And therefore, the value of minus b will be 1 by 4. And so, when you try to find out b, it's going to be minus 1 by 4. Similarly, for the same value of a as 1, what will c be? Well, put a equal to 1 in this, and you will have c upon 1 is equal to minus 1. So overall, c is minus 1. Now with this, you have the three coefficients that you were looking for, a, b, c. So the quadratic polynomial here is a is 1, so 1x squared, b is 1 by 4, negative 1 by 4, so this is what you have, and c is minus 1. So this is just one such polynomial. This is not the only polynomial in the world which is going to have this sum of zeros and this product of zeros. Why? Because I fixed a random value of a here. Somebody else might come and choose a different value of a. For example, let me do one more. Say I choose a equal to 2 now. Then from this first relationship, I will have minus b by 2 is equal to 1 by 4. When I'll solve this, I will get b is equal to minus 1 by 2. Similarly, when I put it here, I will have c by 2 is equal to minus 1, and this will give me the value of c as minus 2. So this time, the quadratic polynomial that I'll have will have this a, this b, and this c. So it's going to be 2x squared minus 1 by 2x minus 2. Let me clear up some space. Alright, so I've tidied this up a little bit. So a equal to 1 gave you this quadratic polynomial, while a equal to 2 gave you another quadratic polynomial. Now the question here also says find a quadratic polynomial each. It does not say find the quadratic polynomial, because of the very reason that there is not just one that you can find. There are many that will have the same sum of roots and the same product of roots. In general, how are you going to do this in the exam? Well, you will write down the answer for a equal to 1 first, and then you will say that any multiple of this polynomial is going to work. For example, let me say that this multiple is k, that I'm going to multiply this with k. Then if I multiply, how will the expression look? This is what the polynomial will look like, k times the original polynomial, the one that I got for a equal to 1, where k is nothing but a real number. It's any real number in the world. All of these quadratic polynomials are going to work. Now a quick check is this one. You will see that this is actually something you'll obtain if you put k equal to 2. Similarly, if I chose something else for a, then some other k, the same k basically what I take for a in this example, will work. So for you, do not get confused with anything. I'll give you your quick steps again. You'll use the relationship for the sum, relationship for the product. You'll take a equal to 1. Accordingly, you'll find out the values of b and c, and then you will get your quadratic polynomial by putting it in this. And then you will finally say that every multiple of this polynomial is also going to work. Let's now look at part 2 in this. Here's part 2. This time you'll see how easy this is, how quick this is going to be. Yet again, the sum of the zeros is square root of 2 and the product of those zeros is 1 by 3. I will straight use the relationships that the sum is equal to minus b by a and the product is equal to c by a. And then I will choose my value of a as 1. Accordingly, when I put a equal to 1 in each of these equations, I will get the values of b and c. For example, let me put it here in the first one. So if I put a equal to 1, I will get the value of b as minus 2. Similarly, if I put a equal to 1 in this, I will get the value of c as 1 by 3. So with this then, my quadratic polynomial ax squared plus bx plus c is going to be how much? It's going to be x squared minus square root of 2x plus 1 by 3. And since you know any multiple of this will also satisfy the same results, will have the same sum and product, your final answer is this. So k is any real number. This is the quadratic polynomial you were looking for. And if it's just one such polynomial, then you can leave it without the k. Let's move to part 3 now. Here you go. Now onwards, I will want you to try first, and then when you play the video again, you will see the solution written. Alright, so here's our solution for part 3. Sum 0, so 0 is equal to minus b by a, product root 5, so that's c by a. Put a equal to 1, get the value of b and c, b 0, c square root of 5. So a quadratic polynomial, one quadratic polynomial that will have this given sum and product is this. This is one where I've put a equal to 1, b equal to 0 and c equal to square root of 5. Basically the three values that we had here. So this is one such quadratic polynomial. And in general, all polynomials which are a multiple of this one, just say it was 0x, so I did not write that again. It's just k times this polynomial where k is any real number will also satisfy these conditions. And we're done. Let's go to part 4 now. Yet again, you know the drill. Pause the video, try this, you play it, and you'll see my solution. Okay then, here's the solution for part 4. So sum and product are both 1. So minus b by a and c by a are both 1. You put the value of a as 1 and accordingly you get the values of b and c. And once you have a, b and c, you get the quadratic polynomial by just putting these values. Now this is one such quadratic polynomial. In general, all multiples of this, for whatever real number you take, will satisfy these conditions. Make sure here that the real number you're taking, this k, is not 0 itself, because if k becomes 0, the entire polynomial will become 0. It won't be quadratic. So it has to be a real number, yes, but non-zero. Now you have part 5. Try this and then play the video. There you go. It's exactly the same. Sum is minus 1 by 4. Product is 1 by 4. Getting a equal to 1 will give you these values of b and c. You put them in your polynomial ax squared plus bx plus c, and this is one such quadratic polynomial that will have the sum and the product that you wanted. In general, any multiple of this will work as long as k is a non-zero real number. Finally, let's go to this last part. Try this and then we're done with exercise 2.2. And here's your last part. So sum 4 is minus b by a, product 1 is c by a. We put the value of a as 1, get b and c. So one such polynomial according to this is x squared minus 4x plus 1. But in general, any multiple of this will work where k is non-zero, a real number. So in the exam, whether you write down this one or you write down any other polynomial, any multiple of this, that is still going to be correct. And we're done.